Hello friends, this is Gangadhar from the YouTube channel Maths Gangadhar. See, in the last videos of number theory, we discussed about the way of finding the number of factors, sum of factors and product of factors for different numbers. Now in this video I am going to take a chance to discuss about the perfect numbers. See, a perfect number is said to be a perfect number for which sum of all its factors is twice the number. A perfect number is a number for which sum of all its factors is twice the number. See, if you list the factors of a number and after listing you just add all the factors, the sum of all those factors, if it is equals to twice the number, then we call that number as a perfect number. Okay, for example, if you have a number 6, write the factors of 6. For 6 factors, what are different factors of 6? Factors of 6 are 1 is a factor, 2 is a factor, 3 is a factor, and then 6 is a factor. There are no other factors for 6. So since these are the factors of 6, if you add all these factors, sum of the factors, the sum is, what is the sum? 1 plus 2 plus 3 plus 3 is 6 plus 6 is 12. This 12 is again 2 into 6. So for 6, if you calculate the sum of factors, the sum of factors is again equals to 2 times of the 6. So we call this 6 as a perfect number. So perfect number is a number for which sum of all its factors is twice the number. For suppose if you have some other number like 12, okay, or some 18, take any number. If you list the factors of 12, what are the factors of 12? 1, 2, 3, 4, 6, and then 12. All these are the factors of 12. If you add all the factors, if you sum the factors of 12, 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 6 is 16, and plus 12 is 28. This 28 is not equals to 2 into 12. So if you add sum of all the factors of 12, the summation is not the twice of 12. So this is not a perfect number, whereas 6 is a perfect number. So finally, a perfect number is a number for which sum of all its factors is twice the number. For example, 6 is a perfect number, and we are going to discuss different perfect numbers now. See, the perfect number is also defined in some other way. What is that means? See, one way we are mentioning that for a perfect number, sum of all its factors is twice the number. See, among the factors 1, 2, 3, 6, okay, we call this 1, 2, 3 as proper factors. We call this 6 as improper factors. Okay, for every number, that number itself is a factor, that is called improper factor. So if you exclude that improper factor, if you exclude the number itself, sum of all the factors excluding the number itself is equal to the same number. For example, if you add 1, 2, 3, 1 plus 2 plus 3 is 6. So sum of all the factors excluding itself is equal to the number itself, is another definition for the perfect number. Okay, so perfect number is defined in different ways. In one way, sum of all the proper factors is the number itself. In the other way, sum of all the factors excluding the number itself is again equal to the number. And the third way, sum of all its factors is twice the number. So for example, 6, you take, the sum of all the factors is 12, so 2 into 6, so it is a perfect number. Okay, in the same way, if you take some other number, okay, see, if you take 28, if you take 28 and list all the factors of 28, what are the factors of 28? 1 is a factor for 28, 2 is a factor for 28, 3 is not a factor, 4 is a factor for 28, and if you check, 7 is a factor for 28. In the same way, 14 is a factor for 28, and then 28 is a factor for 28. If you add all these things, sum of all the factors of 28, 1 plus 2 is 3 plus 4 is 7 plus 7 is 14 plus 14 is 28 plus 28 is 56. This 56 is 2 times of 28. So sum of all the factors of 28 is again equals to 2 times of the number. So 28 is also a perfect number. So if we have a number, to check whether it is a perfect number or not, we need to list all the factors of the number, and by listing, after listing, we need to add all the factors. If the summation becomes 2 times of the given number, then it is a perfect number, otherwise it is not a perfect number. Okay, there are different results related to this perfect number. Okay, see, one of those results is mathematician Euler proposed that if you have a number of the format like some 2 power n into 2 power n plus 1 minus 1, take a number of this format 2 power n into 2 power n plus 1 minus 1, this number is perfect. For different natural values of n, this number is perfect if this 2 power n plus 1 minus 1 is a prime. Okay, if this 2 power n plus 1 minus 1 is a prime, then Euler mentioned that this is a perfect number. See, if this 2 power n plus 1 minus 1 is a prime, see, you just write that number as a prime. So write that n is equals to 2 power n into some p power 1. This p is actually is of the format 2 power n plus 1 minus 1. Okay, see, Euler mentioned that this as a perfect number. See, how can we say whether it is a perfect or not? We will say by calculating the sum of the factors. And in the last videos, we know the way of writing, calculating sum of factors for the given number n. See, for the given number n, whose prime factorization is 2 power n into p power 1, what is the sum of the factors of n? See, to calculate the sum of the factors of the n, the direct rule is 2 power n plus 1 minus 1 divided by 2 minus 1. The formula, this is n plus 1 minus 1 by 2 minus 1 into p power this 1 plus 1 2 minus 1 by p minus 1. Okay, see, 2 power n plus 1 minus 1 by 2 minus 1 and p square minus 1 by p minus 1, this product will give us the sum of the factors of the n. If you simplify that product, how it becomes, this 2 minus 1 is 1, the denominator is 1. Whereas coming for the second term, p square minus 1 by p minus 1. P square minus 1 by p minus 1 is p plus 1. So it becomes like 2 power n plus 1 minus 1 into p plus 1. Now, this 2 power n plus 1 minus 1 is nothing but actually p. See, this 2 power n plus 1 minus 1 is considered as p. From there we started here. So this 2 power n plus 1 minus 1 is p. Whereas coming to here, p plus 1. What is p? This 2 power n plus 1 minus 1 is p. So if you send that minus 1 this side, p plus 1 is 2 power n plus 1. So p into 2 power n plus 1. So sum of the factors of n is p into 2 power n plus 1. And we will write the 2 power n plus 1 as 2 into 2 power n into p. So this is equals to 2 into 2 power n into p. 2 power n into p is n. So this is equals to 2n. So for the number n, 2 power n into 2 power n plus 1 minus 1, if this is a prime, okay, by taking it as prime, then n is mentioned as 2 power n into p power 1. Then for this number, having this prime factorization, if you are going to calculate the sum of factors using the formula, see, it becomes like this: 2 power n plus 1 minus 1 by 2 minus 1 and p power this 1 plus 1 minus 1 by p minus 1, and on simplification we have that 2 power n plus 1 minus 1 into p plus 1. We are initially considering this 2 power n plus 1 minus 1 as p. So the first value is p. And the second value in the product is p plus 1. See, from this p plus 1 is 2 power n plus 1. And on simplification, you observe that finally, sum of the factors of n is 2n. Since sum of all the factors of n is 2 times of the same number n, we mentioned that, we confirmed that this n is a perfect number only if this 2 power n plus 1 minus 1 is a prime. And this supposition, this contribution for the mathematics is from the mathematician Euler. Now, see, the general form of the perfect number, or the numbers having this format will generate different perfect numbers by replacing different natural values in the place of n. So finally, the concluded statement what we have in our hands is 2 power n into 2 power n plus 1 minus 1 is a perfect number if 2 power n plus 1 minus 1 is a prime. So for that, if you take n is equals to 1, if you take n is equals to 1, what will happen? If you take n is equals to 1, n is equals to 2 power 1 into 2 power 1 plus 1 minus 1. So this is equals to 2 into this 2 power 1 plus 1 is 2 square minus 1 is 3 and that is equals to 6. Since this 3 is a prime number, 2 into 3 6 is a perfect number. Okay, right. If you take n is equals to 2, what will happen? Then n is equals to 2 square into 2 power 2 plus 1 minus 1. 2 square value is 4 and 2 power 2 plus 1 is 2 cube minus 1 is 7. Since this 7 is a prime number, 4 into 7, 28 is a perfect number. In the same way, if you take n is equals to 3, then n is equals to 2 cube into 2 power 3 plus 1 minus 1. See, this 2 power 3 is 8 and 2 power 3 plus 1, 2 power 4 is 16 minus 1 is 15. 15 8 is 120. Since this 15 is not prime, so 120 is not a perfect number. In the same way, if you take n is equals to 4, then n is equals to 2 power 4 into 2 power 4 plus 1 minus 1. And 2 power 4 is 16, 2 power 5, 32 minus 1 is 31. Since this 31 is a prime number, 16 into 31, 16, 36 is 480 plus 16, 496 is a prime number. So in the same way, if you replace different natural values in the place of n, all those results will represent perfect numbers only if this 2 power n plus 1 is a prime. And after certain stage, by replacing values, n values, different natural values in the place of n, it is somewhat difficulty to check whether this 2 power n plus 1 minus is a prime or not. If we are able to check whether it is a prime, then we will confirm that the number is a perfect number. Okay, so like that, we will list out different perfect numbers. So the initial perfect numbers are 6, and the next number is 28, and the next number is 496. If you check like this by taking different values in the place of n, you will get the next perfect number as 8128. Like this, we will generate different perfect numbers. Okay, see, basically perfect number is a number for which sum of all the factors is twice the number itself. And later, mathematician Euler proposed that a number of the format 2 power n into 2 power n plus 1 minus 1 is a perfect number if this 2 power n plus 1 minus 1 is a prime. Okay, see how it becomes a perfect number. Already we discussed the proof here. We calculated the sum of the factors of the n. Clearly it becomes like 2 times of the given number n if it is a prime. So this is a perfect number if it is a prime. So by taking different n value, different natural values in the place of n, we will get different numbers for n. All these are the perfect numbers like 6, 28, 496, and later somewhere you will get that 8128. All these are different perfect numbers. Okay, so this is the concept of perfect number. And for the mathematics, there are 2 open questions for the perfect numbers. And from here we need to observe one thing. Okay, later that I will discuss the questions. Okay, see, the one thing is, see, if you take different natural values in the place of n, all those results, okay, if it is a prime number, it becomes a perfect number. Maybe there are some other perfect numbers which are not in this format. See, what the Euler proposed is numbers which are in this format are perfect, but every perfect number need not be in this format. So there may be some other perfect numbers which are not in this format also. Okay, see, the mathematicians are searching for the perfect numbers which are not in this format. Okay, see, so many mathematicians are thinking to find an odd perfect number. So it's an open question whether there is an odd perfect number or not in mathematics. If you think about that one, if you solve it, it becomes a big thing in the mathematics also. Okay, right. So finally, this is a small concept regarding the perfect numbers. Do subscribe for the channel. And then if you have any queries and doubts, suggestions regarding this channel, you just send your suggestions for gems.maths@gmail.com. Okay, I hope this video is helpful for your preparation. If it is helpful for you, don't forget to like it and do refer it to your friends also. Thank you.